Hi, everyone. Welcome to the Trident stage and welcome to ETH Denver 2024. Our next speaker is Zhen, CEO of Web3 Auth.
Thank you. Hey guys. Hi Denver. How's everybody doing? Is it a fresh morning? I'm feeling a little bit jet lagged to be honest, but glad to be here for sure. The spark whales are a lot cuter this year. I was checking one out. I'm Zhen. I'm one of the co-founders of Web3 Auth. We are the leading wallet as a service company that provides social logins to wallets and via account abstraction, MPC, and more. We power Gnosis Safe, Animoca brands, and a lot of other both Web2 and Web3 brands that you guys might know and have heard of. Today I'm going to be talking a little bit more about, let me just get this out. It's a bit weird. Okay. Today I'm going to be talking a little bit more about something a little bit more technical. I'm going to talk about Passkeys and basically enabling face/touch ID on wallets and on your applications so that you guys can go off and try it out and kind of like play around with it yourselves. So before that, just want to do a quick lay of the land, right? Who here knows what passkeys are, even in the first place? Okay, most of y'all. And who here also know what account abstraction is? Okay, also everybody. And also, fantastic. That's just perfect. Who knows about WebAuthn? Okay, I'm surprised. Okay, yeah, that's great. Okay, so most of you kind of know what passkeys as a construct are. Passkeys are an implementation of WebAuthn, which basically is a interface on your browser or also on some native devices that allow you to use your hardware enclave key pair to sign and authenticate to Web2 applications. Now, although passkeys and the user experience is really nice and seamless, it actually looks a little bit like this. This is me doing it on my Mac. I was just doing it last night. But basically, you can see that I just use my Touch ID on my Mac, and I'm basically into the application or into whatever I want to do, right? So Passkeys is also a trend that has been pushed out by large industry giants, including Apple, Microsoft, and y'all know that already because most of y'all know what Passkeys are. Some of you might have felt the experience on applications that you guys already know and love. Coinbase in particular just launched it, I think, a couple days ago or last night. Binance has it, GitHub, you know, all of these nice applications have passkeys. And now today we're going to learn a little bit more about how these are implemented and how also y'all can do that in your application yourselves as well. So first steps, the first thing is, right, digesting kind of like the flow and authentication flow of passkeys themselves and how that works. So this is just ripped off from the website directly itself. You'll see that there are two main parties over here. The first party is the relaying party server, and this is the server that's looking to authenticate the user, looking to digest and understand and make sure that the user is who they say they are. And the second one is the authenticator. The authenticator, and as well as the browser and all that, lives on the user's device. And that's the second stakeholder here. Now, the flow of authenticating a passkey is simply the relaying party server issues a challenge. This is not too different from what you think a OTP is or an email, a passwordless email OTP might be. It typically is a string. You can configure it as the relaying party server, and you issue that challenge to a user's front end. Then it's ingested by the JavaScript on a user's website or user's on the website that your user has loaded up. The WebAuthn API is then called. It hits the browser, and then it hits the authenticator. Now, authenticators are actually generalizable. There are lots of different authenticators out there. Passkeys is a form of a authenticator. In particular, that like Google and like Apple have implemented on their phones. But I'm not sure. Do you guys know like YubiKeys or let's see, YubiKeys. Authenticator app is different, but YubiKeys and all of these different hardware keys that you might have played around with before, that's also forms of WebAuthn authenticators as well. But today we're specifically talking about Passkeys. And so the authenticator will basically sign on the challenge that's been issued. This challenge is then propagated upwards. Generally, a new public-private key pair is generated for each credential that we're talking about signing on. And that's also relayed upwards in step number 4. And finally, last but not least, it's relayed through the browser and passed back to the relaying party server where we see server-side validation. So how do we add crypto into this? How do we add a connection to the blockchain into this, right? So the way we do it is, and this is the first way to kind of naively implement this, would be steps 1 to 5 are basically exactly the same, right? But afterwards, the public key as well as the credential is relayed via, like Infura or whatsoever, on-chain in particular, into on either a smart contract wallet or a account abstracted setup, right? On-chain and just used the signed object which was received back from the relaying party server is used as verification and is used as an intention for a user interaction. So we would basically choose to edit the challenge, right? In step number 1, we would, instead of just issuing a random nonce or a random challenge to the front end, we'd actually issue maybe a set of commands, something like transfer 20 USDC. We then sign. We then go through the same process, sign, relay that object through the gas relay in step 6, and then it goes on chain and is verified on the contract. The signature itself is verified on the contract itself. Now, this is a naive implementation, right? A naive architecture of how this would be done. Can anybody kind of spot what's wrong with this implementation just outright if we were just to do this? If we were just to take a WebAuthn signature or a passkey signature and put it on chain, can anybody spot something that's wrong? I don't know if we have a Q&A and mic, but you guys can shout. Anybody? What? Wrong curve. Yes, it's WebAuthn is a wrong curve, but that's why we're actually doing the signature validation on chain in step 8 relative to it. He mentioned wrong curve, and that's absolutely correct. WebAuthn signatures do not comply with ECDSA or SCCP 256K1 signatures. And therefore, we need to validate WebAuthn signatures specifically on-chain. And while that's correct and accurate, that wasn't the problem that I was trying to point out here. Can anybody else see potentially what's wrong in this naive setup? Again, we're just taking a signature and we're relaying it on-chain and intending that that is a interaction that the user wants to do. For example, in step 1, we're saying, hey, you want to send 20 USDC, and we're just relaying that on-chain, and that acts as verification for the account abstracted wallet to then move forward. Anybody? Okay, so the problem is actually replay attacks. In particular, So in particular, it's replay attacks. The main issue here is that if I choose to try to send 10 USDC outwards, right, and a signature from WebAuthn describes my intent to do so, once I relay that transaction on-chain, this transaction is public. People can see it. People can basically take the same WebAuthn signature, this same the same intent, right, and replay it. So for example, if I Zhen, were to send Bob $10 and I actually had $100 in my wallet, Bob could take that same signature and replay that 10 times, right? Because it's the WebAuthn signature that we're verifying on chain, because the curve is not compatible. That describes my intent to send money. How will we fix that? Does anybody have a fix to this now that we've outlined the issue? What do you say? Yes, that's right. Use a nonce. He said use a nonce. So basically, we just have to add a nonce on chain that describes part of the intent. It's not unsimilar to the transaction nonce that you might typically implement. So you just add a nonce, and this nonce will increment. It can start at 0, and that means that every signature that you sign on is unique because of that nonce. And if it's not signed on a incrementally, increasing nonce, it's just not a valid signature. Yeah, and that basically is more or less a basic, a very high-level interpretation of how one can implement passkeys into an account abstracted setup. So us at Web3Off, we've done this with a couple of clients and a couple of companies, and we've made a lot of mistakes along the way. Passkeys is a relatively new concept. It's a relatively new thing for users to be adopting. And as such, in production, you actually face quite a few issues here and there. The experience is great in general, but definitely one of the biggest problems is that passkeys themselves, or WebAuthn, works super well on Apple and some of the latest Apple versions. But on other devices, on like Windows, on like Androids, they don't work so well. There's a lot of different versions of Android. There's a lot of different versions of Windows, a lot of different manufacturers, and there are issues with passkeys implementations across them, right? Another thing is definitely there's extra cost for the verification. In particular, because the chains are not compatible, you are paying an additional component for passkey verification, which is on-chain verification, which can be costly. And then last but not least, so it's about like, the last I checked is about 15 to 20 cents on Polygon, and quite a bit more expensive on mainnet. And then last but not least, there's actually a centralization risk with the relaying party solver. So passkeys, as well as WebAuthn in general, are application scoped, meaning that there has to be a relaying server party issuing the challenge and receiving the challenge as well, in particular. This is required by the domain specification, and it's enforced by domain ownership and like DNS ownership, right? So if somebody, basically you are dependent, your passkey is dependent on that specific domain to be used. And if this domain goes down, they can't steal your money, but they definitely can, you basically can't use your passkey anymore. So some implementation recommendations so that you guys don't commit the same mistakes that we do and some of our early customers did are definitely, with passkeys, what you want to do is you definitely don't want to use passkeys in a silo at this point in time. What I mean by this is you don't want to use passkeys as the only signer to your account abstracted wallet or the only signer to your to your account, essentially. Why this is the why this is the case is because passkeys are, well, not exactly as robust. There are edge cases. People do lose them, and you don't want people losing accounts on your different implementations. No Web2 implementation that exists today includes just a passkey login into a user account, because recovery is an issue. The second thing is the second thing is just to add on that, you definitely, you can use it as a alternative login as the first factor, but you can also use it as a second factor, like a 2FA, as per normal, as per normal. Last but not least, you want to restrict your implementation to compatible browser and OS setups. So, for example, Chrome and iOS just don't work with Passkeys. You won't be able to access your hardware enclave via Chrome. Passkeys is a very specifically Safari integration. So on iOS, you only want to allow Safari, and if the user is not on Safari, you don't want to enable this feature because it just runs into read routes. And this is the same on Chrome Android. You only want to allow Chrome Android or Chrome and Windows Edge/Chrome as well, in particular. Yeah, I mean, that's about it. And I hope you guys enjoyed this little snippet. And I can take some questions, actually, if there's any time for Q&A in particular. Anybody has any questions or anything they want to double-click on here? Yes, sir? So the Coinbase implementation is a very interesting and novel implementation. For those of you who don't know, the Coinbase implementation is they have your main key, right? Your main smart wallet that is on Coinbase wallet itself. And then they basically use passkeys as session keys for dApps and applications to use and sign without having to go back into the Coinbase wallet to confirm each and every transaction. So what they're using passkeys as is essentially they're using passkeys as session keys for dApps. I think it's a good implementation because even though you lose your passkey, you never lose your original account with Coinbase. You just lose your session key and your session on that application. You can rehydrate it, and you can create a new passkey for that dApp, so there's no concerns of loss. I think it's quite an innovative and novel approach of using passkeys, and I think it's really cool. Any other questions? All right, OK. Yeah, you can find us here. If you guys want to use social logins in your applications, do hit up Web3 off. We also have recently released our Passkey SDK as well as our Farcaster login SDK. So if you want to do login with Farcaster into your application, do check us out as well. Unfortunately, we aren't sponsoring ETH Denver this year, so we have no prizes to offer. But toodaloo. That's it. Thank you, guys.
Thank you so much, Zhen. Stay tuned. Our next talk is at 11.